Hello, and thank you for joining us today as we discuss the benefits of a LiDAR-based occupancy monitoring system. My name is Lisa Shaw, and I'll be your moderator. I work on the marketing team at SICK. During this webinar, you will learn why our LiDAR solution is the best choice for monitoring occupancy levels, how the PeopleCounter solution from SICK operates, and where you can use the PeopleCounter to help slow the spread of COVID-19. Just a little housekeeping before we get started. A recording of this webinar will be emailed to you following today's presentation. Also, feel free to ask questions at any time during today's webinar by typing your questions into the Q&A box in your control panel. We'll take some time at the end of today's presentation to address as many questions as time allows. Now I want to turn our time over to today's presenter, Aaron Rothmeyer. Aaron is a National Product Manager for Ranging Products with SICK. In his role, Aaron is expert in LiDAR, analyzing market trends, and finding growing markets where LiDAR would be beneficial. He also helps lead SICK's TIM 10K Challenge, with supporting innovation in LiDAR technology in colleges and universities nationwide. Aaron, please take it away.
Absolutely. Thank you very much for the introduction, Lisa. I'm happy that everybody was able to join us today to talk about this important topic. As you mentioned, I've been with SICK for a while now, talking about LiDAR, and this product is probably the most important product that I've had the opportunity to talk about because it really gives us the ability to protect people in everyday environments, not even just within an industrial environment, but within everyday environments. So I'm happy to spend a few minutes talking about it with the group here. As Lisa mentioned, if you've got any questions, please do type them into the chat window and we'll address them at the very end. So what we're going to try to cover today is a brief introduction of just why are we doing people counting. I think most of us probably have a pretty good idea, but just to recap real quickly, we'll cover that. Then we'll jump into how we do people counting with the MRS 1000A people counter. And then I'll show you real briefly, I've got one wired up just over my head, and I'll show you real briefly how easy it is to set it up and how reliable it is. And then we'll compare that to kind of some of the other concepts that are out there for people counting. And then at the end there, we'll have a little bit of time for questions. Probably won't take a full hour, maybe take about 45 minutes or so, depending on how many questions there are. But again, if you do have questions, do type them in. I'd love to address them there at the end. So the current situation, this is our global view, and admittedly, this information is already out of date because it's changing every single day. But the information that we have from global view is that there is still, this pandemic going on. There is still a need to monitor crowds, and the way that most governments recommend that we do that is by essentially doing one of a few things. One is certainly physical distancing, making sure that people are separated from each other by some distance. In the US, they typically recommend about 6 feet. Another is by monitoring the maximum capacity. So that's what we're mostly going to be talking about today. So if you've got a room that the government says can only hold 50 people, well, we have to make sure that only 50 people or less are in that room. And then some governments also recommend limiting the amount of time that you're exposed to other people in public spaces. That's another just kind of common global regulation. And then, of course, regulations are changing, frequently as well. Not quite day to day, but certainly feels like it sometimes. So there's further regulations that are out there and more that are certain to come as the situation changes. So most of what we're trying to address today is just regarding that maximum capacity characteristic, which we just want to make sure that we understand how many people are in a given space at a given time. And by the way, this is actually not a new application for LiDAR. It's certainly a new situation for all of us, but the application isn't new. We've been approached several times over the last few years just to monitor the number of people in certain areas. For example, consider secure areas like in an airport, for example. In many places in an airport, you want to know not only whether or not there's a certain number of people in an area, but also what direction they're heading. There's even retail areas where you want to know how many people are spending how much time within a certain area of a room. So there's lots of reasons to monitor the number of people in the area, COVID or no COVID. So because of those reasons, we came up with what we're calling the MRS 1000 PeopleCounter. And as we'll get into, there's a lot of reasons to use the PeopleCounter. There's lots of features and benefits and such, but at the end of the day, the PeopleCounter is exactly what it says it is. It counts people, which, again, compared to some of the other devices that I represent, the PeopleCounter is kind of nice because it really only does one thing. It counts people, and it does so very reliably. And so one of the things I'm looking forward to here in this presentation is showing you how we connect to it and how we configure it, because there really isn't, it's not rocket science. We can plug into it, and I'll show you very quickly just how easy it is to configure. So the PeopleCounter, as it stands right now, is basically a standalone device. You don't need to wire it into any kind of plant management system or building management system or anything like that. It's just a standalone sensor that has the capability built in to look for people traveling underneath it and determine the direction of travel. And I'll show you how that works on the next slide. But just as a concept, that's really it. So over here on the right, you can see there is a PeopleCounter sensor mounted against the ceiling, and it's looking down. This is actually in front of our canteen and one of our German offices in front of the cafeteria. So it's sitting here, and it's looking down. And if you'll picture it, there's basically an invisible wall in front of or below this the sensor. So a vertical invisible wall. Invisible wall is made of infrared light. Basically, it's a series of laser pulses that we're sending out to measure the distance. But for all intents and purposes, it ends up looking like just basically an invisible wall. So as people break that plane or series of planes, as they travel through it, we can determine the direction of travel. And the way that we do that is really interesting because we actually do a lot of contour detection or profile detection to determine whether or not it's a person. But the end result, again, is very simple. We just get a count of whether or not people are traveling in or they're traveling out. And it's neat because one of the key details here is that is fully anonymous. There are other systems out there that attempt to determine the direction of travel of people. A lot of them are video-based. And certainly there's some benefits to using a video-based technology, but in a lot of cases, there's also security or privacy concerns as well. Many people are not pleased with having the picture taken every second of every day, and just adding more cameras can actually be more of a hassle than one might expect, just because now once people recognize that they're being videoed or having pictures taken of themselves, there can be a lot of pushback from that. And we've seen that mostly so far in secure areas where, if you're traveling in a secure area, there's a good chance that having a picture taken of you as you travel in there is not a good thing, or even just a private area, for example, a restroom. There's plenty of situations where we wouldn't want a camera outside of, say, a restroom as people are traveling in and out of it. So the LiDAR data that we're collecting, we can tell the contour, we can tell enough of a shape to tell that, yes, it is a person, but we don't capture anything, identifiable like a face or anything like that. So it's a pretty neat technology, and I want to show you how it works here. So this next slide shows the concept, which is basically we put it above a doorway, very simple concept. We can use either a single device above a single doorway, or if you've got multiple doorways, for example, a lot of rooms now have an entry door and an exit door, just to maintain one direction of travel through a room. We can handle that as well. So these devices are actually connected together. We can use Ethernet to basically master slave them. So one master will maintain the count, and then the slave, whether it's in the same plane as the other device or whether it's in a different plane entirely, it could be across a building if you had an Ethernet cable long enough. But that slave then reports its count back to the master, and the master maintains that current count of however many people are in the room. We can also do what's called multiple use, which, if you've got many exit doors and a single entry door or some configuration, or maybe you've just got a whole bunch of doors and they're all in one row, like in this example where you've got just a very large entryway. We can handle that as well. There's really no limit as to how many slaves we can put on that one single master. So if you've got a very large area, we can cover that using multiple people counters as well. The concept is this. This is basically our people counter device. You can picture that mounted essentially above a door. As people walk underneath it, we basically break up the invisible wall that I mentioned underneath it into 4 distinct layers. And so here we label those layers A, B, C, D, just arbitrarily. And the concept is basically as a person walks underneath, if they break planes in one order, say A, B, C, D, then we determine that that person is entering a room. We know that they're traveling in that direction. If they go the opposite direction and they break the planes in order D, C, B, A, well, now we know that they're traveling in the opposite direction, and we, basically say that they're leaving the room. So it's a really simple idea that basically takes advantage of the hardware that we've designed called the MRS-1000. It's multi-layer capabilities. But just due to that, now we've got a direction of travel. The cool part about that is that this invisible wall, it can be, as I'll cover later, up to about 12 feet wide or so. So in that 12 feet, if we've got people traveling simultaneously in both directions, or even traveling at the same time in one direction, we've just got a whole bunch of people traveling in one direction, we can count them all individually. It doesn't matter if they're side by side or, if they cross at exactly the same time. Because we're looking at the direction of travel as they break those planes, and we can segment it up so that it doesn't matter if they're traveling in single file or side by side. But we're also looking at individual contours. So that's the portion right above it here. For these red dots, if you're not familiar with LiDAR, this might be a little cloudy, but regardless, these red dots represent the profile of what is traveling underneath the sensor. So you can kind of see here, in most cases, you can kind of see basically a head and shoulders, right? So in this middle picture, ID6, you can kind of see a head shape with shoulders. And it looks a little cloudy because basically we're looking at it from the side when what the sensor sees is actually from the top. So it's a little odd, but regardless, what we were able to do is use some pretty intense machine learning algorithms to go through and look at basically 1,100 different profiles of people. So these 1,100 different profiles, we pushed them into this deep learning or the machine learning algorithm, and we said, this is what a person looks like, in 1,100 different varieties. As they walk, as they run, shorter people, taller people, all kinds of different instances. We just pushed them through this algorithm. And what we got out of it is the ability to not only determine direction based on those 4 planes, but also the ability to say, yeah, that's a person, as opposed to that's a shopping cart, or that's, a backpack that's being swung behind you or something like that. It really allows us to take it a step further and not just determine direction of travel, but also get a little bit of intelligence built into there as well. So it's a pretty exciting thing to see the background, at least for me. But at the end of the day, really, the result is a super easy to use, super reliable, and very anonymous detection of the number of people walking into a room. So what does it look like to actually install this thing? Pretty easy, actually. You can see the one above my head is actually just mounted on a flexible bogan arm that I threw up there real quickly, just clamped it on. It's not really very critical, as far as angular alignment and such goes. We can adjust for that in the software. The real limitations are outlined here. So we've got a mounting height that's between about 5.9 feet, or we'll say 6 feet, to about 11.5 feet. So I usually round to about 6 to 12 feet. If you can get it within that window, that's about where we're going to be able to be successful. It makes sense to me because if you go any lower than 6 feet, well, that's a forehead hazard for most people. If you go anything above 12 feet, well, now if you go above 12 feet, basically we're not getting enough data back for our algorithm to work correctly because they're getting so high. The measurements all get spaced out. So you want to try to keep it between about 6 feet to 12 feet. If you've got high ceilings, say a 30-foot ceiling or something, we just have to be able to mount some kind of gantry or some kind of mounting arm to bring it down to about 12 feet. Now, if you bring it down to about 12 feet, that means that your coverage side by side or side to side is about 12 feet as well. So in some cases, you're going to have 12-foot wide doorways, you know, a large entryway or something like that. In the case behind me, you know, it's a typical 30-inch door or 36-inch door. So, you know, it just basically depends on what type of entryway application you have. One key detail that we've got right now that I want to point out and make very clear up front is that the algorithms that we designed based off of those 1,100 profiles are designed to detect adults, essentially, anybody above 4 foot 7 inches. Basically, the reason for that is because we wanted to make sure that we got a product out to the general public as quickly as possible, and we didn't have access to any profiles that were below 4 foot 7. Nor did we have the ability to test anybody that was below 4 foot 7. As you can imagine, you know, testing a situation like that where, you know, you'd have to bring together a bunch of people, kids, essentially, that were under 4 foot 7. We wanted to try to avoid that given the current pandemic climate. So for the time being, we've got a stipulation that anything under 4 foot 7, we can't guarantee we're going to be able to detect. We'd like to add that functionality later, but for the time being, we're looking at applications where, you know, mostly adults are going to be the targets. So just want to make that clear up front. So with that in mind, as long as we're mounting between 6 foot and 12 feet above the ground, we've got greater than 98% detection rate of anything that travels underneath it. And so with that power, you might think that, you know, there's a lot of configuration that goes into it, but really there's not. And I'll show you exactly what that looks like. I've got a few slides ahead of us that I'd actually like to avoid and just jump over right to the programming interface. So what you see here is my Chrome browser. Any internet browser will do, but whatever internet browser you use, you jump in and there's a web server built right into the device, a very smart device. It's easy to program and access. And so all you have to do is just type in the IP address of the device, which from the factory is 192.168.0.1. And this is what you see. It pulls up a web server that's hosted right on the device. So as long as you've got an Ethernet connection to it, you're in. Real briefly, the first thing you want to do, and I'm not going to go too in depth into how to actually, you know, configure and program all of this, but you want to make sure that you log in as an authorized client because that gives you access to make changes. If you were not to do that, if you were just to plug into it and not to log in, you'd end up with read-only access, which will allow you to see everything that's going on in here, but not change any of it. And that's just a, you know, basic security function so that not anybody can just go and start making changes to your device. So we'll bypass this. This is all just basically communications information. The real meat of the topic takes place right here, where we call it the teach-in screen. And as you can see right now, it says counter active is on, which means we are currently in counting mode. If we wanted to make changes to this, for example, we just took it out of the box and we plugged it in, we're ready to start programming it, we'd want to turn that off. So we click on it. Now I'm in programming mode where it says counter active off. So when I'm in programming mode, you can see these red dots are fluctuating. These fluctuating red dots are basically showing me that it's capturing live data. So if I were to, well, I don't know, push my chair over there, you would see the red dots move. It sees something. And if I bring it back, then I can go ahead and start configuring. Configuring this thing is super simple. All we have to do really is tell it where the doorway is. That's pretty much it. So these blue bars on either side, are indicating my current settings for the doorway. I can drag them and they'll move. If I've got a super wide doorway, I can drag this thing all the way out to the edge. One other thing to mention here is that if you've got a doorway that isn't actually defined, say you set this thing up in the middle of a courtyard and you just want to know how many people walk down the sidewalk at any given time, you can set it up regardless of what your door looks like. If it's just a sidewalk traveling through a courtyard, set it up overhead and then just drag these sliders until you're covering the area that you care about. So it could be a wide open expanse, and you can still just go ahead and just define only the area that you care about. And once you've done that, you end up with basically this corridor that you actually care about. We would call it an area of interest or a field of view. And then you kind of want to make sure that the floor, which is shown here in red, this horizontal red line, you want to make sure it's roughly level. So I did an okay job of mounting it up there with my flexible arm. If I move this, you can see basically it accounts for whatever offset I put into it. If I put it at about 0.5, that makes my red floor nice and horizontal, which makes the algorithm nice and happy. From there, there's not a whole lot else to do to set it up. There are a couple things you want to keep in mind. For example, the switch direction of in-out. When we talked about the ABCD DBCA or DCBA, that can be reversed. So when you mount it, depending on how you want the count to increase or decrease, you can check that box to make it operate correctly. There's also a couple other things like daily reset. So you can set it so that basically every night at midnight, it'll go ahead and reset the count. The reason for that is because, as I said at the beginning, we've got a 98% detection accuracy, which is really good, but that does leave 2%, which if there is any kind of error, we don't want that accumulating day to day, because then at the end of the day, well, I should say like at the end of the week, there's going to be a much larger error than we would like. So if you're worried about a accumulating error, we can set up a daily reset so that at the end of the day, boom, it goes back to 0 and you start fresh again the next morning. Auto start after reboot and reset counts after reboot don't really need to be addressed here, but essentially it's just a configuration option so that when power comes back up, it can basically go back right into operational mode and reset that count. Probably the most critical thing here, once you've got the area of interest set up, is your room capacity. So there are two modes that most people use when we're talking about the PeopleCounter. There's counter mode, and then there's room capacity mode. So counter mode is essentially what you would expect. It's a continuous count. I'm going to finish my teach-in here by clicking counter active. There we go. So when I'm in counter mode, it'll tell me essentially how many people have come into the room and how many people have left the room. So if I walk in or I walk out, real briefly. If I walk out and then I walk back in, you can see it says, hey, one person went out, one person went in. It also gives you a timestamp. It tells you roughly how tall I am, 1.81 meters. It tells me how many times it detected me as I walked through that door. And it tells me roughly where I was in the field of view, that relative position. So all that information is there in counter mode. And this information can be sent out to a variety of, if you want to run it into a building management system, or you want to run it to a display so you can get a continuous count of how many people went in and how many people went out, that information can be fed out through Ethernet. The other mode that we would want to talk about is called room capacity mode. And as you can imagine from the beginning, there's definitely a need in the market to know the current population within any room. So that's what room capacity mode does. And I set it back here in teach-in, on the teach-in screen, where I say current capacity of this room is 2, small office. So if it was a much larger room, say I could fit 50 people in there, I would enter that value into this window. And then I can set a threshold for when I'm going to get a warning. So right now, I've set my threshold to 50% so that when one person is in here, me, I can say, okay, only one more person can enter and then no more. And so that value can either be displayed on the screen or we can use digital outputs to signal some kind of indicator, like for example, a light. We can use, say, red to say capacity has been reached, 2 out of 2, no more people can come in. We can use a yellow light to show that we're getting close to capacity. And we can use a green light to show that the room is empty, for example. And that's all pretty easy to wire up, actually. In a second, I'll jump back and show you what that looks like in the presentation. But then the last thing to see here, this is a value that, or this is a screen that we're using to basically capture statistics. This is an ask from some of our test customers so far. They want to know, from midnight to midnight, how many people have entered and how much time they spent in there, what the capacity is at any given time of the day. So we're building out this statistics screen to basically capture that and determine, what the usage or utilization is of the room at any given time. So you can already see here, based on this log that I've got in here, on this particular day, around noon, we had 2 people in there. And then around 1 o'clock, we had 1 person in the room. And this can be stored, it can be offloaded to a separate server for analysis and determining who was in there, or how many people were given in there at any given time. So these modes that we've got are basically the reason for the people counter, so that we can determine either how many people are going in and coming out, or how many people are in there at any given time, the total count. So I hope I've conveyed that it's relatively easy to set up. The beginning, all we did here was basically drag some bars and set the orientation, and we're good to go. So it's a really impressive device just to get up and off the ground. So we're able to skip over a few slides there, which is nice. These are the outputs that we have available. Back to presentation here. So real briefly, the Ethernet, again, this is a smart device. It uses Ethernet not only to configure, but also it uses it for outputs. So if you've got a high-end building management system or something like that that you want to try to get a current count into with that timestamp data, we can feed that out over the Ethernet port. We've got all kinds of assistance on how to actually do that. It's basically just a matter of sending a command out to the sensor, and it responds back with the current count. We also have a variety of I/O available for this device, so inputs and outputs. The outputs primarily on this are being used to either increment a count. So if you've got, say, a 7-segment display or some type of counting device, we can send out a pulse every time somebody walks in or walks out. We can also, as I mentioned, light up like a red light or a green light or an alarm or something like that using those outputs as well. And then just a real quick note about power. Power is pretty simple. We do have basic wall wart transformers available that'll feed out 24 volts that you can just go ahead and plug it in, plug and play. Otherwise, anything 10 to 30 volts DC, if you've got that available, it can be run into this this connection, and we've got power. So pretty straightforward. We do make it, we try to make it as easy as possible to get these accessories. We've got all the part numbers available. We've got the signal lamp for red, yellow, and green in stock if you want to try to wire that up. We can even sell it as a kit. So if you just want the devices sent to you in one package and you go ahead and connect everything together and you're ready to go, we've got that kit set up in the system as well. We're trying to make it as easy as possible to get this device mounted up and ready to go. We're also expanding this into basically more of a system standpoint as well. So this device down here is called our TDC. The TDC is, well, it's telematic data collector is what it stands for. And it's essentially just a kind of like an edge computer sitting there right next to the MRS 1000, so that any data, any information about counting people comes out of the MRS 1000, goes right into the TDC, and then it's made available wirelessly or over a cellular connection to any kind of monitoring system that you want. So we can do all kinds of interesting things in here. You can see this is basically like a dashboard, which shows the current count, and it shows trends as you go through. So this is a system that we're working on expanding as well, so that really you can take advantage of all the power of the PeopleCounter. So the PeopleCounter, because of the current situation and just because of the other technologies that are out there, it's actually not the only people counting solution on the market. In my opinion, it happens to be the best, but you know, I might be a little biased. It's a fantastic technology though. Being LiDAR based, again, we're not capturing any kind of personal data, so there's no worries about privacy. Because it's LiDAR based also, we're shooting out our own light. We're not relying on ambient light or anything like that. So if the lights go out, we're not concerned about that. And then also, we've been doing LiDAR for a really long time. So we're really capable in less than ideal environments. So I think in a lot of cases, this will probably be put in a pretty ideal environment, like an office like behind me, where we don't get a lot of rain or snow or fog or anything like that. But if it is put into a situation, say, I don't know, outside of cold storage, where somebody opens up a walk-in freezer and a bunch of fog rolls out, we can handle that as well. It's a very robust measurement because it's based on that nice LiDAR technology. And we do have a fantastic video that we put together that I'll just play real quick for you. There's no audio, so don't worry about audio. I'm going to try to play it in its entirety, but I'll pause it from time to time just to expand on what's going on. First few seconds basically cover what I've already discussed. Right now, there's definitely a need in the world to know how many people are in any given room. Right now, it's often done manually. You know, we've all seen the guy standing outside the door, making sure that only a certain number of people enter. That's fine, but it's often prone to issue or failure. And of course, then you've just got a guy sitting there all day long counting people, which is a tough job. So by putting sensors in place, we can make it a little more automated, a little more reliable. That's really, you know, that's what we're all about here at SICK. So there's other solutions out there. One example is PhotoEyes. And I relate this kind of basically to, you know, the same sensor that you might find underneath a garage door, where it's what we call a break beam or a through beam, where as people walk in, they're basically breaking one beam and then the other. And based off of that, we can kind of try to determine the direction of travel. The issue with this is that there's just not enough data there. All you know is that a beam has broken. You don't know where it's been broken. You don't know, what is breaking it. You're not doing any kind of profile analysis or anything like that to determine what actually traveled through that door. All you know is that that beam has been broken and then the other beam got broken. So, for example, in this case, if these two people walk through side by side, it could be 80 people side by side, depending on the width of the doorway. And all we know is that that beam has been broken. So that's one of the major drawbacks to this technology, is that there just isn't that resolution to say, oh, that was two people and they were traveling, one was traveling in, one was traveling out. There's just not enough data there for it to make that determination. The other thing here that I mentioned briefly is that if you, say, push an object through or pull an object through, all it's knowing is that that beam has been broken. It doesn't know that it's a person, it doesn't know that it's a cart. For example, a shopping cart being pushed through here would cause a series of triggers, as the grating or the mesh of the shopping cart turns it on, turns it off, turns it on, turns it off. I can't imagine what it would do to a count pushing a shopping cart through. So in this case, you can see she pushed the cart through and turned on and turned off and turned on as she walked through. So again, leads to inaccurate counts just because you just don't have that amount of data. The other key here is that With the PeopleCounter, we're mounting up above, as I've got shown behind me. Pretty unlikely to hit that with anything because I'm going to hit the door frame first. With the through beam technology, it's got to be mounted at the side, ideally, waist level or above. And so that puts it in a prime position to be hit by something. If you're pushing a shopping cart through, or if you just lean into it, it's in a position where it can be hit. And as soon as it breaks that alignment, as soon as it can't see the other device on the other side or the reflector, it won't be able to detect anything. So then you've got an issue where you've got to come out and provide service or some kind of maintenance. So by mounting overhead, we've really got a key location or a prime location where we're probably not going to be damaged by anything traveling through the doorway. So in comparison, we've got the PeopleCounter. I've already covered that's basically a multi-layer LiDAR. It's got basically multiple planes that you break as you walk through, and it's mounted out of harm's way. As the woman walks out of the building, we can tell that she's left, the occupancy goes down. As people walk in, occupancy goes up, regardless of whether it's a single person walking through or multiple people. And of course, we've got the light over here that we can use just basically to indicate what the current capacity is of that room or what the current fill level is of that room. So it's a great technology. Like I said earlier, it's really just an extension of what we've been doing for years. It's really cool. And if I jump back here, just to summarize real briefly, we've got some really nice benefits. Number one, just that it's anonymized. So we don't capture any personal data. It's reliable. We've got a counting accuracy in excess of 98%. And it's robust. So if you've got a situation that isn't ideal, for example, if you've got low lighting or precipitation or something like that, we're going to be able to handle that just fine. So I'm hoping that there have been a few questions as we've been discussing. If you haven't sent in your questions yet, feel free to go ahead and send them over to Lisa via chat. I'd be happy to answer them. Lisa, have you come across any questions yet?
Awesome, Aaron. Yes, we have a few questions. The first question is about swinging doors. So the question is, does the unit compensate for a swinging door opening into the plane of view?
So a couple of things happen when you have a swinging door enter the field of view. Number one is that it's going to look at it and ask whether or not this is a person. And the answer to that is no. It will look at the profile and say, this is not a person, and it won't detect it as a person. The issue is that when the door swings open, you're also going to have what I would call an occlusion or shadow. So it won't be able to see through the door if there's a person walking behind it. So ideally, if there's a swinging door, we would mount it on the other side. And there's no problem with that because we can always reverse direction. But if there is a swinging door passing through it, it won't detect the door as a person, but it could shadow people. Maybe we can mount it higher, or ideally we would mount it on the other side of the door.
Great. And this question's a little long, so it's in your chat, but I can read it slowly.
Okay.
The question is, can you pull a live screen? Sorry, I'll read it again. Can you pull a live screen of the capacity to a CCTV system as a, quote, camera view direct from the web server showing only data as a HTTP or HTTPS stream?
I'm going to go ahead and say yes. The two ways that I think you can do that, one is the screen that I showed earlier showing the capacity. But I think what you're asking more is for like a custom interface, which we can get through using a JSON configuration, where basically we can request information from the web server on the PeopleCounter and then display that in a custom interface. So I think the answer to your question is yes, but we'd probably want to delve into it offline. Good question.
Great. Joe asked a simple question, and maybe we can follow up with him after this webinar, but he asked, what was the kit part number?
I don't quite have it memorized yet, but
Sure.
I can scroll up real quick just so that everybody can get it if they need it. There it is, 1114292.
Awesome.
And you can see it comes with basically the device, the PeopleCounter, stack light, which by the way is pre-wired, so there's already a connector on the end. You just plug it in. And then this box on the left, if I didn't describe it, is basically a connection box. So these three plugs plug right in the back of the PeopleCounter. And then if you've got bare wires, power wires or Ethernet wires or output wires, you can land them right in this box in the on the terminal strip.
Awesome. The next question is what is the maximum distance between separate enter and exit doors for one PeopleCounter to be used between both of them?
I suppose that would be 12 feet. Because as I said earlier, if you mount it 12 feet off the floor, we assume about a 90-degree opening angle would be best for the algorithm. So that gives us 12 feet at the bottom to cover. If you got more than that, if you got more than 12 feet between them, we'd recommend using 2 and then just running an Ethernet cable from one to the other.
Awesome. The other question is, how would you recommend mounting for revolving doors?
Oh, good question. And we've tackled this one before, actually, because the question came up almost immediately when we started talking about the PeopleCounter. Essentially, you can't mount it in the revolving door by any means. You got to mount it either on the entry or the exit of the revolving door. So yeah, basically, we decided that if you step it back just far enough, say 6 inches or so away from the actual revolving portion of the door, as long as we've got that clearance and it's not seeing, the door, it does just fine because people walk in, they go into the revolving door, people walk out, they come out of the revolving door, they break the planes, and it works just like any other door.
Great. The questions keep on rolling in, Aaron. So the next one is are there any limitations to using it for an outdoor event?
Great question. No. With saying that, I want to clarify that, I showed you how you configure it. So it is a flat plane. So this isn't a device that say you're going to, mount above an open area and just look down over say an entire courtyard. It's a plane, it's a threshold they have to pass through. So in an outdoor event, if you've got, say, a ticket booth or something where people are being funneled towards this gateway, this threshold, as long as they're passing through that threshold in a controlled way, we're looking down from above and we can count people going in and out. If you're thinking about just like ambient environments, say bright sunlight, cloudy days, rain, snow, we're not concerned about that at all. We're designed to work it's an IP67 device, and we use all kinds of technologies to mitigate precipitation and stuff. So very easy that way.
Awesome. Has the device passed any government PEN test for network security?
Greg's bringing the great questions. Network security is a #1 priority for us. We've already been asked about security in a lot of situations. The pen test in particular isn't one that I'm familiar with, unfortunately. I can tell you that we do have a secure network that has passed a lot of tests for network security. However, I'd have to look into that particular one to make sure. I haven't seen that anywhere in the documentation, but I can get back to you on that.
Awesome. This question comes from Kevin, and he asks, how many days can the unit collect time and date information on people coming in and out?
Is a rolling log. which I believe stores up to 32 logs. So that would be 32 days. And then once you complete, that 32, you go on to day 33. It'll cut the prior day and just keep on rolling for the last 32 days.
Cool. And then George asks, is there a special PN or is it just MRS 1000 with special software?
Awesome question. It is a special device. So there is a special part number. It is 111-2242. Again, that's 111-2242. And it's a special device. So if you just order an MRS 1000, you're just going to get that data. There's not going to be a PeopleCounter app loaded onto it. So if you want people counting, don't order that. There is also a third version that is designed to be loaded with apps such as this one, but it doesn't come with a PeopleCounter application installed on it. So the one you want, if you're looking for a PeopleCounter, is 111-2242, and that'll come preloaded with a PeopleCounter app already on it. You don't need to do any kind of loading of apps or doing your own software development. So, good question.
Awesome. I see one more question, but any other questions we have after this, I'm happy to share Aaron's information, and I will be sending an email out afterwards, sharing the recording, and I can also share Aaron's contact information in there as well. But the last question we'll answer is, can it be powered by PoE or PoE Plus?
Good. Like a lot of camera-based devices that use PoE, we've looked into that. It has not been included on this version of the PeopleCounter. So it can't natively be powered by PoE. Of course, if you've got, say, an injector with a splitter at the end, you could run PoE up to it and then just use a splitter to pull that out and separate into our separate connections. But it's not a power over Ethernet PoE device natively.
Great. Okay, so one more question did pop in, so maybe we'll do this as our last one. This comes from TJ, and he asks, if a customer already has AppSpace and MRS 1000, can they use App Manager to use this?
Yes, contact me. I can get you the app. We'd love to send it out to you so you can go ahead and do the testing. For any full installations, of course, it'd be beneficial to just go with the PeopleCounter. If you've got a customer that wants to actually buy one, we recommend that so that, say, there's a return down the line or something like that, it gets properly handled. But yeah, if you just want to load it onto an MRS 1000C, MRS 1000P, the AppSpace version, you can go ahead and do that. Just contact me and I'll send you the app.
Great. Thank you so much, Aaron, and thank you for all those who participated in today's webinar. Please visit psych.com to learn more about the product, but also stay in the know on our upcoming webinars and trainings. Thanks again, Aaron, and have a great day, everyone.
Thanks, everyone, for your time. Have a good day.